Hey, it's Joel. I'm at Smurf, and I'm next to my friend Jacob from Construct3D.
It's good seeing you again.
Good to see you again.
Year.
It's been a great year. And actually, I'm standing in front of some things that we got to see last year, but now there's this new hotness, and you've been teasing it on social media. So I have to ask Jacob, what's going on here?
Okay, so as we already know, we already sell machines, and those are what we now call the designer class model because of data.
Well, getting a machine and coming up with something from that data is like, that's your happy place. And so this is where that came from, right?
So of the requirements, the biggest one was heated chamber. If you are printing the max build volume, 75 degrees.
Okay.
Actively heated 75 degree chamber.
Really? Okay.
And it's temperature modulated. So we have temperature sensors all the way throughout the chamber. So it will self-modulate only the bits that you need. So as the bed goes down, it will actually pump more heat in because obviously the top bit will be hotter than the bottom bit.
That's fantastic.
I
didn't even think about that, but that's
air circulation fans to then remix that material. So then you get the hot in the cold and the cold in the hot.
Okay. Oh, that's great.
Right.
Okay.
We've got temperature sensors in the nozzle, in the top of the chamber, in the middle of the chamber, right above the heater output. We've got a peaker heater, which is basically an underpowered heater because you don't want the same maximum output as the bed. Because then you've got way too much power and you can't plug it into a regular wall socket.
Oh, so this is still rated for standard sockets?
Still one socket.
Oh,
so
okay.
the bed, which is 800 watts, does the majority of the heating. But then you can cool the bed down to whatever printing temperature you want, and the peaker heater will maintain and then raise the temperature at a slower rate. And then we have an exhaust fan that then can bring the temperature down as it slowly creeps up over time.
And it does that all automatically?
All automatically.
Oh, I love that. There's a lot of magic happening.
Oh, yeah.
You set one thing and it just follows the flow. I get that.
Going back to the industrial side is networking. Factories have notoriously bad internet connections. They also have notoriously bad internal networks. If you've put it next to a plasma cutter, you will probably destroy your machine very quickly. That is just a risk of industrial design.
So then, okay, using that data then, how do you go about mitigating it?
You harden the machine and you give it more network options. So now this machine has Wi-Fi and Ethernet. It's powered by a single board computer. This is a Raspberry Pi 5.
I love the detail that we're diving into this. And so
it's important.
But so a Raspberry Pi 5, that's hardening the network?
So it gives you multiple connection options, keeps all the networking inside, and it actually has a lot more high pass voltage frequencies. So it stops it dying sooner. But then the other side is it can work fully headlessly. So if there is no internet connection, there's no network connection, there's not even a computer, you can now run the entire printer on its own. So on the front, we have 2 USB ports and a HDMI output connector, so you can put your own monitor, keyboard, and mouse and fully control the printer without needing to externally connect to anything.
So if we're talking about light industrial or medium industrial applications, that HDMI port, was that because of comments? What I'm wondering is, have people wanted to put their own size, like status monitors?
Yes.
Oh, okay.
This one is now 335 by 390 by 400.
That's huge.
We've made we're actually working on making it a little bit bigger still.
Okay.
This is a prototype serial number 0. So there's some micro changes still to be done, like we're adding a camera in, so we've got internal monitoring, 12 megapixels what we're aiming for. So
nice.
Nice 4K.
Not a potato.
Not a potato. But that also leads into future upgrades. The reason we chose a Raspberry Pi 5, it's got compute headroom. So with extra compute, you can now start offloading processes to possible plugins in the future. So if you want a more advanced spaghetti detector that can utilize the camera a lot better than it currently can, you can just plug it in and you've got that headroom. It doesn't affect the printer at all. If you need even more, you can use the interconnects between the motherboard and the Raspberry Pi, rip the Raspberry Pi out, and you can put an AGX NVIDIA Orin to have massive amounts of compute.
Oh,
this is a future-proofing
I didn't
machine.
even think about that, but being able to offload compute-heavy processes, especially I know a lot of medium industrial, light industrial, they like Grafana. They like having all of these stats piped out so they can graph them over time. And that's going to be compute-heavy in places that may not have headroom.
Especially if you're monitoring things at very high frequencies. There's a lot of data throughput, and you don't want that to affect the printing. You just want to capture it. And it gives you the option of future-proofing.
Now let's talk about the head on this thing and the motion systems. Is it a Core XY?
It is a Core XY. Okay. It's actually the same motion system that we use on our Construct 1 series.
Oh, okay.
Because it works. We don't need to go any faster. We don't need more accelerations. We're already at the top golden tier of speed. What we needed was more flow rate. So we've doubled it.
You doubled the flow?
Yep.
So what is the flow rate on this?
Every material has a different viscosity.
True.
So PLA, depending on the blend, is 32 cubic millimeters a second.
Okay.
And that is on a regular PLA, not a high-speed PLA. That's a pet peeve. Don't blend polyethylene and PLA and call it PLA. Just tell me. Just pet peeve.
Okay, that's fair. Standardizing on a default non-high-speed PLA is great because that's what everybody has.
I know.
Yeah.
PETG is 45 cubic millimeters per second.
Okay.
ABS and ASA is 60, and polycarbonate is around the 40 to 42 area.
Those are great numbers.
They are really good. And that is 100% non-cold core printing. We're using an E3D roto as the hot end, and that is fantastic because it will stall before it cold core prints. So if it is pushing plastic, it is basically guaranteed to be 100% molten.
That's cool.
But it's great because for materials that warp, having a fully molten material versus a semi-molten material stops the polymer chain from shrinking, so your prints print better every time. As you can probably see on the head, there is a lever arm for a upcoming add-on filament changer.
Oh.
Yeah, we've been doing a lot of work on that, making it industrially ready and easy to maintain because materials can be fickle.
Yeah, sure, but when we talk, okay, material changer, this is something you're not like, this isn't a BQ thing, they're
no,
vivid. This is a Construct3D
Yeah.
filament changer.
In theory, you could plug an external one in and get that working. I know BQ are working on maybe an integration with the Wetpack firmware.
Yep.
But we're working on our own. Like,
Jacob, that's news. Like, that's huge news.
well, you actually saw the prototype of the prototype last year. This is mad scientist.
Okay.
There is no guarantee this will become a product.
The prototype of the prototype.
It almost worked.
Sure.
So of what we're aiming for, it's either 3 4-kilo reels or 6 1-kilo. We've
Okay.
actually got one version that's 12 1-kilo reels, and then it will do hot swapping between the reels as well. So it will
Jeez.
then have material rollover and color changing, which is a nice added like usability feature.
Rollover is wonderful, especially in those
I prefer rollover.
Oh, those industrial, like the ability to have rollover and just like queue up a bunch of spools and then just use them up and then, yeah. Talked about the BQ, the multi-material, being able to load stuff underneath.
Yep.
Was there any further thoughts on that?
The last one, for especially for industrial areas, you get lighthouse color systems. So we've actually used the LED strip on the inside.
Okay.
They're all fully color coded. So green means it's starting a print, yellow means you need to watch it because something might be going on. Could be the first homing sequence. So you need to watch, make sure it doesn't go
in
wrong.
progress,
Like
watch,
in
like
progress
something's
things. Like
happening.
literally just watch me. If something happens, be here in case it goes wrong. Red means it stopped itself. Like something critically went wrong, go wrong. Purple is like a critical failure. So it's basically asking turn me off immediately. You should never see purple. If you do, run to the machine straight away.
That's fair.
But then you've got intermediary codes. So if it's flashing red, it can mean the extruder's jammed. If it's flashing orange, the filament has run out. So it allows for a lot of easy diagnosis from a glance from halfway across the factory.
Right, I mean, having a shelf or shelves of these, you could be like, oh, 2 need this, 3 need
Yep.
this, 1 needs this.
Straight
What's
away.
blue, Jacob? What's blue?
Print finish, the best color.
I feel validated.
You're
that one.
welcome.
Yeah. A lot of really cool features in this,
Well,
and
thanks very
really, I love that you're building this based on feedback from customers because they're the ones that are going to be taking this off your hands.
They're the ones that use it, and they're the ones that need a better experience.
Yeah.
And that's what we live for, is making their lives easier.
Well, the only thing left to do now, I know we got a little bit of the show left. Plenty of people are going to have questions, but once they see this, they're going to want to know more. So look in the camera right there and tell everybody where they go to find out more about
Go to
Construct3D.
construct-3d.com. You won't find this on the website yet, but when the page goes live, that's when you can start ordering it. If you want it sooner and want to pre-order, send us an email and we'll get in contact with you.
And they can do that via the website, contact
Yes,
you, right?
all website
Yeah.
contact. If not, just look at my face on Twitter or social medias or anywhere else and you'll find me.
I like that. All right, well, you know, I like to offer my audience a high five at the end. Are
Oh,
you up
yes.
for it again? All right,
Hell
here we
yeah.
go. Well, listen, if you made it this far, you're awesome. Don't forget to hug each other more. Fight for a cause you believe in. Medium industrial, print all the things. Yeah, all right. And as always, high five. You want one? Oh, it echoed. Yes.
That was good.